In this video, we are going to start to talk about conversion factors that are unique to chemistry. We're going to be filling out this handout that's on page 104 in this video, and then in a separate video we'll be doing some directions and examples. Let's first take a look at this handout. All right, we're going to add some stuff to this. So if I write it, you should write it. This is going to be eventually glued into your notebook, page 104. See if this one is better. All right. So we have equivalencies, and these are things that are equal to each other. They're equal. And then we have conversion factors, which I usually abbreviate CF, and they are fractions. And these two are one and the same. So our first equivalency in chemistry that's unique to chemistry is that atomic masses are equal to a mole. But we learned that already. So this is nothing new, right? Keep in mind that atomic masses are for elements, and they are measured in grams, right? We know those things, but just as a reminder, those tend to be things that we forget as we move through this particular section or skill in chemistry. And this is an equivalency, but we can write it as a conversion factor, which is a fraction. The word looks weird. All right, so we can write it as the atomic mass. I'm going to abbreviate it so it'll fit over 1 mole. Or you can write it as 1 mole over the atomic mass. It doesn't matter, this is one and the same, but we can flip that fraction for whatever we need. I'm going to write them as both, just so you know that it can be flipped. The next equivalency is molar mass, and we already learned that it's equal to a mole. Molar masses, as a reminder, are for molecules and compounds. I'm just going to write compounds here. But again, it's a mass, so it's measured in grams. Right? And the same thing here, we have the fraction or conversion factors for this. So you would do molar mass over 1 mole, or 1 mole over molar mass. It depends on how you need this arranged. Now, this one's a bit different, but we know this already. This is Avogadro's number, so we have 6.02 times 10 to the 23rd particles is equal to a mole. We also learned that already. Now, particles, this is a generic word, right? So particles could be atoms, molecules, compounds, right? Those are some of them. Ions. It could be any of those things. So these are substitute words for the word particle. As you notice, this one has numbers for both. We have a 6.02 times 10 to the 23rd. That's a number, and this is also a number. This one is different than the above two, because we would have to go to the periodic table or calculate these masses, so we don't have any number that we can put in for that. So this one is going to say 6.02 times 10 to the 23rd. I'm going to do P for particles right now, because I don't have a lot of space, over 1 mole, or 1 mole over 6.02 times 10 to the 23rd particles. I have some space there. Those are the two arrangements of the fractions. There's no other arrangement that you can do. All right. The next one that you were going to need that is not familiar. This one we have not looked at yet, and we're going to need it to convert between different chemicals. So it says number moles A is equal to number moles B, and you're getting the numbers from a balanced chemical equation. So remember, when we balanced equations, we're going to need the numbers, specifically coefficients. I'm having a hard time spelling that word right now. Coefficients. Oh, struggle. Right, 2 F's. Right, we're going to get the coefficients. The numbers are going to be the coefficients from the balanced equation. So this would go number mole A over number mole B, or number mole B over number mole A. And you might wonder what A and B is, and I kind of forgot to tell you that. These are generic placements for chemicals. So these would be chemicals. Right? So it depends on your balanced reaction. Right? There's a zillion different reactions, so we're going to use generic representations for the equivalency. All right, moving on to this one is for gases. All right, this is for gases. It's got to be a gas. And this is an equivalency, but again, this one's easy because look, we have numbers already. So we just do, and it has to be a gas. And 22.4 liters of a gas is equal to a mole. So these are the two arrangements. And hopefully you're seeing the pattern that I'm just flipping it. The last one, anything that contains both numbers and units can be used as a conversion factor. All right. The example is density, and the number of grams for density would equal a mole. So I'm going to go get actual density because this one tends to be weird for students. I won't do water because water is 1. Who should be? Let's do carbon dioxide. I think most of you are. That's not a scary chemical. Alright, so for example, carbon dioxide, CO2, has a density of, this number would get replaced with the number 1.98 grams is equal to 1 milliliter. Alright, so the number would be replaced by the number of grams. This box is a little bigger. I think I could do both. I'm going to do the generic on top. So the generic would be the number of grams over 1 milliliter, or 1 milliliter over the number of grams. And for CO2, that would look like 1.98 grams over 1 milliliter, or 1 milliliter over 1.98 grams. Alright. And the last part is percent composition. We talked about this, but we have percent compositions, which are some sort of number of grams. I probably should have had a number there. Number of grams of the part is equal to 100 grams of the whole. So this would look like some sort of number of grams of a part of a chemical over 100 grams of the whole thing, or 100 grams of the whole over, over the number of grams of the part. We probably won't talk about this one a lot. there's some discrepancy between the district and the state, and percent composition isn't listed in the state requirements. So we'll see how time goes. If we have extra time, I will show you that. Alright, so I'm going to zoom out. Sorry. Alright, I do want the rest of this in here so you can see the whole thing. I will focus it. Right? Right, so these are equivalencies that are unique to chemistry. They are unique to chemistry, and you want to complete this and glue it onto page 104 in your notebook.